All right. In 1-point theory, they're asking us to find the sine, cosine, and tangent for each of the following reference angles. We see one of them, 150. That's going to be in quadrant 2. 7 pi over 4 we'll have to convert. And 300 is going to be in quadrant 4. 225 is in quadrant 3. So we have a couple examples, one from each of the other quadrants that's outside the first one, okay? Let's just start by drawing it. Let's just go to problem A here. Let's just draw 150. Okay, I'm actually gonna zoom in here so it's a little easier to see everything. You may want to write really small. If this is too small for you and you need to grab another piece of paper, that's totally fine. Okay, there's going to be a law on this circle. All right, 150 degrees on this unit circle here is going to go past 190. I'm sorry, past 90, but not hit 180. It's going to be closer to 180. Halfway in between would be 135. And so it's going to be right about there. So this is going to be 150 degrees. Now we saw in the slider video that this could be drawn, we could save a lot of work if we drop a parallel to the x-axis here and use not the 150 part, but the extra 30, we basically already have done this triangle. Okay, we've basically finished it. Okay, so we see that the 30 and the 150 are going to add to the full 180, right? But we're going to use this 30 instead of the 150 because it doesn't really matter which side we draw on. If we draw the triangle anywhere we want, we can still end up with that same point here on the unit circle. Sorry about that parentheses. Okay, so if I've got a 30 degrees and a 90 degrees, I know I've got a 60 degrees. The tiny side is across from the tiny angle, so 1's over there. Root 3 would be right there, and the hypotenuse of 2. Now remember that's from the last video, so make sure you go back and look at that. The only thing I want to adjust here is that this x side is not positive in this quadrant. So that actually wouldn't be a positive root 3. It's going to be a negative root 3. Right? Because that's what the points we're seeing here. Now the y is still positive in this quadrant, so we're going to leave that 1 alone. The up and down is still positive. And since it's a triangle, the hypotenuse is always going to be positive. The unit circle is representing the radius. Radii will always be positive. So the only thing that's going to change is this negative root 3. After that, I can just go find my sine of 150, cosine of 150, and tangent of 150. By doing SOHCAHTOA. So 30 across, opposite over hypotenuse would be 1/2. Adjacent, negative 3 over 2, root 3 over 2, and tangent negative, 1 over negative root 3. So right, I'm just doing SOHCAHTOA. Opposite over hypotenuse, adjacent over hypotenuse. Sorry, I'm at school right now. And opposite over adjacent. All right, this last one we do need to rationalize, so we'll times by a root 3. Move the negative to the top, or times by 2 negatives. We get negative root 3 over a positive 3. Sweet. Cool. Let's go do it again. Now, we're not going to take 3 hours and do every single angle here because they're all going to end up about the same. But I want to do a couple from each quadrant to kind of show you what you would get. So let's do this next one here. We have 7 pi over 4. I don't know about you, it doesn't pop into my head really fast where that is. So I think I'm going to convert that to degrees. 180 over pi. That would be 45. And 7 times 45, 315. Okay, see, I think I can get a better idea about where 315 is. I think 315 is going to be down here. Boop, boop. In between 270 and 360. And it's actually halfway in between 270 and 360. So this is 315. Once again, we'll go ahead and drop a triangle back to our x-axis to get that 90 degrees, right? We don't want to go this way, even though it's halfway and we'll end up with the same thing. It's just a good practice to just go to the x-axis so you can play off that first quadrant a little better. We never drew any of our triangles in the first quadrant to the y-axis, so it's not a good idea to do it in any of the other ones, okay? Now when I do that, I notice what would be left over here. 315, 360, take away that 315, this is going to be a 45. And therefore, I have a 45, 45 triangle. From the last section, we know that that means the sides are 1 and 1. I'm just going to clean this triangle up a little bit. And then the hypotenuse would be root 2. Okay, that's something we need to commit to memory from our cheat sheet. So we don't have to memorize this whole circle, right? Cool. X's here are positive, but let's adjust for those y's. The y's are negative. Then hypotenuse shall always remain the same because Pythagorean theorem has squares. You don't want to do squares and negatives, right? All right. Now I've adjusted for the quadrant. Let's go find sine of 315, cosine 315, and tangent of 315. And notice I'm writing down the original degree number, not 45. I'm just borrowing 45, right? I'm just borrowing that triangle. All right, sine would be opposite -1 over hypotenuse. Rationalize, you get negative root 2 over 2. Cosine would be adjacent over hypotenuse. Rationalize, you get a positive root 2 over 2. And tangent would be opposite over adjacent, or -1. Cool, we have those three. Moving right along to 300. Let's do it again. 300, a little easier to see where it is. That's going to be a little less than 315, but a little more than 270. So here we are. We'll drop that triangle back. I'm going to go ahead and zoom in so I can make this a nice pretty triangle. That's the 300. Oh, no. All right, so now we see that that's the 300 degrees. It gives us that really pretty right triangle. All right. Now, if we think about it, what's left over? Left over would be the 60 degrees right here. And so we have the 60, 30, 90 triangle. Much more skinny on this side, right? But we still have that 1, 2 relationship. So we have small side 1, hypotenuse 2, and root 3. Okay, I'm going to make my pen just a little bit thinner. Okay, now we can find sine of 300, cosine of 300, and tangent of 300 using this triangle. Okay, so opposite over hypotenuse gives us root 3 over 2. Whoops, I apologize. I forgot one very important thing. This triangle is not in quadrant 1, and the y's here are negative. So I want to make sure I put a negative on that root 3. But the x's here are positive. So the cosine will still remain 1/2. The tangent opposite over hypotenuse will be a negative root 3. Okay. Let's do another one. 3 pi over 2. We will come back to, we're actually going to do 225 degrees first, just because this one is guaranteed to be in quadrant 3, which I think we need to see. So 225 is in between 180 and 270. It is in fact halfway between 270 and 180, and 180 and 270. So here's that 225. Now remember, I know it's tempting to want to draw it to the y-axis, but we still want to go back to the x-axis, always to the x-axis, just because that's what we did in the first quadrant. And now we see that double reflection. We have 45, 45, and we can use a 45, 45 right triangle. However, in this quadrant, both the x's are negative and the y's are negative. So we have two negatives here. Even so, the hypotenuse will still be positive. All right, now we have sine of 225, cosine of 225, and tangent of 225 degrees. Because we already accounted for that quadrant shift, right, with the negatives, we don't have to worry about like adding the negative later. And so we just have opposite over hypotenuse, which would be negative root 2 over 2. Same thing here, negative adjacent over hypotenuse, also a negative root 2 over 2. Tangent is going to be opposite over adjacent, or in this case, back to a positive one. Alrighty. I'm actually going to go ahead and change this last one from 2 pi over 3 I apologize about this. I don't like to change the notes in the videos just in case you don't watch videos, but I want to make this 2 pi. So just 2 pi. You can even just keep it there and just erase the over 3 part. And we'll see why in the next video. These last two examples, 3 pi over 2 and 2 pi, better known as 270 and 360 degrees, we're going to do in the next video because they're very similar to what happened with 0 and 90 degrees. And I'll see you there.